Okay, so good day everyone. So for today, we're going to discuss about the unified modeling language. No? So when we say unified modeling language, it is a comprehensive, standardized approach to technical diagramming. No? UML actually started in 1997, if I'm not mistaken, with the Object Management Group or OMG. Adopted the UML standard. There was no unified way to model structural diagrams for designing large enterprise applications because UML provides a way for enterprise architects to visualize their designs that anyone who knows UML can understand. Now, there are certain questions that what is UML, why was UML created, who created UML, and why should you use UML. Most commonly, there are two basic types of UML diagrams. No? Familiar tayo sa static and dynamic. No? So each example diagram for this discussion represent a particular aspect of hypothetical applications called the discussions of our actually. So the application is a system that delivers an educational discussion according to the discussion. So large enterprise applications, those that execute core business operations and sustain a business. And to give us more details about the topic, let us all welcome our first presenter. Go ahead, sir.
Good afternoon, guys. My name is Ivan Julius Escritor, and I will be discussing today is about UML dynamic model innovation. So, in the introduction of the UML notation, I describe the model language used to define dynamic behavior of system. What are those? State charts.
Or baka ma-extend mo pa yung boses mo, sir. Thank you.
Mahina talaga boses ko, sir. And state charts or what you call state machines. Collaboration of diagrams, sequence diagrams, and activity diagrams. Now we're going to discuss first is state charts. State charts focus on dynamic behavior of objects and graphically represent the life history of objects over time and their patterns of intercommunication. So state charts are used for real-time design such as robotics, GUI designs like screens and modes. So if you can see in the graph, these are the elements of state machines. So the different parts of a state machines are, first is the states. This is the rounded corner boxes containing state names. And then that is called states. Next is called transitions. Transition arrows from one state sources to another target labeled with event that consists of transitions. Last one is the default initial state. This one is the state of the object at start of its life history. Termination of state chart can be shown as a bullseye symbol. And so there are two different kinds of dynamic modeling notation. Protocol state machine, tsaka behavior state machines. Protocol state machines, the base role is to define when and on which condition can individual behavioral features of owning instance be invoked. So it is described the allowed life histories of objects of a particular class. In this case, the events on transition correspond to operations of that class, and transition may have pre and post condition. Behavior state machine. It defines behavior with focus on how our states of system changing as reaction to an event occurrences. So it is used for describing method, execution, and the implementation of object behavior. Transition of such state machines do not have post condition but can have actions. So this is the example that I got from umldiagrams.org. This is an example of a state machine diagram showing bank automated teller machine or ATM. So initially the ATM is turned off. Ayan. And then after having a power supply or kapag binuksan na natin siya, doon na siya mag-start mag-run. Parang kapag ino-open natin yung mga computer natin, 'di ba? Parang pag inopen na natin yung CPU, magra-run na yung BIOS. So yung parang yung run BIOS niya, ayun yung parang self-testing or self-test na tinatawag. So next step, pag naglagay na tayo, ayan, naglagay na tayo ng card dun sa machine, pupunta na siya dun sa idle. After sa idle, ayan, card inserted, papunta sa serving customer to
Basta
perform
save po,
different
ano,
transaction.
papalit na lang, wait lang.
Ayun, to perform serving transaction. So serving customer state is a composite state with sequential substates, customer authentication, selecting transaction, and transaction. Customer authentication and transaction are composite states by themselves, which is shown with hidden decomposition indicator icon. Ayan. So serving customer state has triggerless transaction back to the idle state after transaction is finished. The state also has exit action eject card, which releases customer card on leaving the state no matter what caused the transition out of the state. For this one, in event of the protocol state chart normally corresponds of the operation methods of class whose behavior as the state chart describe the semantic meaning of a protocol. So meaning yung sabi daw, state chart semantics, each object of class begins life history in default state of state machine. If objects is in state S and event A occurs on object, then if there is a transition labeled with sources, transition occurs, object moves into target state of transition. If no transition from state S, object remains in state S. So yung example dito is a traffic light. Traffic lights are usually traffic responsive. So when signals are operated exclusively on timers, each direction is located in a specific period of time. So ayun, bawat ilaw meron ng kanya-kanyang timer. So kapag green, go, amber or yellow light naman means wait or slow down. Stop naman sa color red. Next, transition guards and action. Transition may have guards and actions. Guard is evaluated when transition occurs on object. If object is in source state of transition. If guard is true, transition takes place. Otherwise, it does not. Action on transition describe events generated when transition occurs. Usually operation invocation on objects of supplier, classes of state machine class. Transition from one state to next denoted by lines with arrowheads. A transition may be trigger and guard an effect as you see in the picture. Trigger is the cause of the transition. We should be assumed that in event of changing condition or the passage of time. Guard is a condition which must be true in order for the trigger to cause the transition. And the effect is an action which will invoke directly the object that owns the state machine. As a result of the transition, so as you can see in the example, an effect is associated with transition. If the target states had many transition arriving at it, and each transition had the same effect associated with it, it would be better to associate the effect with the target state rather than the transition. State actions. Action written following forward slash after event guard if present. Multiple action can be specified, separated by slash or semicolon. Action can be include updates feature colon equals value of local attributes or rules or invocation of operators on supplier objects. Post condition of operation express its state independent behavior. Action of trigger transition express its state dependent behavior. This can be done by defining the entry action for the state. The diagram that we are seeing right now shows a state with an entry action and an exit action. So now the question is, what are the rules applied to states with a state machine? For each state, an event of a state machine, at most one unguarded transition from A from S. If several transitions for A, all must be guarded and have disjoint guards. So impossible for more than one that be true once. For simple state machines, an object is in exactly one state at all times after its creation and before its destruction. So when to use or not to use the state machines? Yes. At an early stage of software development, when behavior of an object or life cycle or operation is not well understood yet. But do not use the state machine when several objects are involved. Interaction diagram are better. Other examples of states under state charts. Composite state chart. States can be nested within others to express relationship of generalization or specialization and to simplify diagram. It can be used to group states into logical compounds and thus make the state chart more comprehensible. In other words, a composite state is a state that contains one or more other substates. It can be used to group states into logical compound and thus make the state chart more comprehensible. When a composite state is entered, its entry node denotes the substate to be activated. As you can see in the graph, it shows an example of a composite state of containing substates. The standby and no power when switch off occurs in state on. It simply goes to standby and the default state is still off. The switch on occurs if the system is in either standby or no power. The next state is on, so the nested state notation therefore reduces the number of transition arrow by 1 in this case. Next example is the nested states. It is used to model the complex system as the regular state diagram is inadequate in describing the large and complex problem. The nested state diagram is the concept of advanced state modeling. So as we can see on the example diagram of a diagram of a vending machine. So magsisimula ulit yung machine sa idle mode. Ngayon, pag dumating na yung tao or nag-insert na tayo ng coin, tapos nakapag-select na tayo ng item, kung hindi available o kaya naman insufficient yung coins na hinulog natin sa machine, magwe-wait na ano na, parang doon na magte-take ng another action kung i-dispense ba natin or i-refund ba natin yung coins na hinulog natin or magdadagdag ba tayo ng coins para makapili ng ibang type items na kukunin natin. Basically, pag magdispense lang siya, magdi-dispense lang siya kapag sufficient na yung nalagay natin na amount dun sa machine. Next, history states. History states remember what substate of a composite state was last occupied. History state written as an H with a circle. Ito daw. If composite state not previously occupied, default substate of composite state is entered state. In the graph that we can see, it contains state charts describing life cycle phases of a product and development process. It consists of 4 phases. If the product development is suspended, the state chart control is passed to the suspended state. When the company decide to resume the product development, transition is taking the control is passed to the history state inside the composite new product development statements. This history state instantly passes the state chart control to the state that was active when the product development was suspended. So yung next part of the UML dynamic notation is interaction diagrams. So what does it mean by this kind of diagram? It is used to describe some types of interaction among the different elements in the model. This interaction is part of dynamic behavior of the system, shows the relationship among object and the message they exchange. So the purpose of the interaction diagrams are follows to capture the dynamic behavior of a system to describe the message flow in the system, to describe the structure organization of the system, and to describe the interaction among objects. There are two kinds of forms of interaction diagrams: sequence diagram and collaboration diagrams. Sequence diagram emphasizes on time sequence ordering of messages, better for visual overflow, while collaboration diagram emphasizes on the structural organization of the objects that send and receive message, and better for visualizing all the effect on a given object. So there are two kinds of form of interaction diagrams. I mean sequence diagrams. So let's talk about sequence diagrams. Yeah. Sequence diagram revolve around the 5 main elements: order placement, payment, order confirmation, order preparation, and order serving. If the sequence of event changes, it can cause delays or probably it may have system crash to it. So it's important to select the notation that matches the particular sequence within the diagram. In this kind of diagram, what are the benefits on using this diagram? So it's easy to maintain and generate, easy to update according to changes in a system. They allow for reverse and forward engineering. And the possible downside is to become complex with too many lifelines and varied notations, easy to produce incorrectly, and depend on your sequence being entered correctly. Next, collaborative diagram. There are 3 primary elements of collaborative diagram: objects, links, and message. If we talk about objects, object participating and collaborating come into two things: suppliers and clients. Suppliers of objects are the objects that supplies the method of being called and therefore receive the message. On the other hand, client objects called the methods on supplier objects and therefore send messages. We have also the other one, which is what you call links. So the connecting lines drawn between the object in a collaboration diagram are what you call links. This kind of links gives part for the sequence diagram. It enables you to see the relationship between different objects. Each line represents a relationship between the objects and symbolize the ability of objects to send message to each other. A single link can support one or more messages sent between the objects. This is from the sequence diagram where the line between the object represent messages sent from one object to another. And last is the messages. So in the messages, in collaboration diagram, it shows the arrow pointing from the client object to the supplier object. Typically, message represent a client invoking an operation on a supplier objects. And what are the benefits on using collaborative diagram? It emphasizes how lines connect. They focus on elements within a system rather than message flow. They provide an added emphasis on organization over timing. However, they can become complex. They make it difficult to explore specific objects within a system, and they can be time consuming to create. Next is behavioral diagram. It is intended to provide clarity, for example, about internal process, business process, or the interaction of different systems. Depending on the diagram used, a selected aspect is shown. In the UML objects are modeled that can change their states through behavior. Basically, behavioral diagrams show what should happen in a system. They describe how the objects interact with each other to create a functioning system. So one of the models under of this is what you call the activity diagram. Activity diagram. It is used to illustrate the flow of control in a system and refer to the steps involved in the execution of a use case. It focuses on condition of flow and sequence in which it happens. It portrays the control flow from a start point to a finish point, showing the various decision paths that exist while the activity is being executed. So an activity diagram shows business and software processes as a progression of actions. This action can be carried out by people, software components, or computers. Activity diagrams are used to describe business processes and use cases as well as to document the implementation of system processes. Now, what are the five basic components of this kind of diagram? We have the action, decision mode, control flows, start node, and end node. First, action, it is a step of an activity wherein the user of the software perform a given task. Next is decision mode. If we say decision mode, it's a condition branch in the flow that is represented by a diamond. Usually use the diamond in flowcharts. Next, control flows. If you say control flows, this is another name of the connector. So this is composed of arrows. Then start node symbolizes the beginning of the activity. So it represents the black circle. And last is the end node, which represent the final step of the activity. So to have more discussion, let's take a look of the symbols that we usually use in a activity diagram. So as you can see, this is the most common type of symbols that we usually use in UML diagrams. So ito yung start symbol. Represent the beginning of process of workflow. Activity symbol indicates the activities that make up a modeled process. Connector symbols show the directional flow or control flow of the activity. Joint symbol combines two concurrent activities and reintroduces them to a flow where only one activity occurs at a time. Fork symbol splits a single activity flow into two concurrent activities. Then decision symbol, two-path branching condition. Ito naman yung note symbol, communicate additional messages. Send symbol indicates that a signal is being sent to a receiving activity. Receive signal symbol demonstrate the acceptance of an event. Shallow history, pseudo-state symbol. represent a transition that invokes the last active state. Option loop symbol allows the creator to model a repetitive sequence with the option loop symbol. Flow final symbol represent the end of the specific process flow. Condition text placed next to a decision marker. And then end symbol marks the end state. So ito yung pagkakaiba ng activity diagram tsaka ng flowchart. So kung if we're going to look at it, it is almost the same on what we know pagka ginagamit natin yung flowchart, di ba? So ayun, ito pala. Ang basahin natin yung difference ng dalawa. Activity diagram is a graphical representation of workflows of stepwise activities and action with support for choice, iteration, and concurrency. While a flowchart is a diagrammatic representation that illustrates a solution model to a given problem. The activity diagram helps to understand the business process or workflow of a system, while flowchart helps to analyze and design a program. Activity diagram is associated with UML, while flowchart is associated with programming. The main difference between activity diagram and flowchart is that activity diagram is a UML behavior diagram that represents the workflow of stepwise activities of the system, while flowchart is a graphical diagram that represents the sequence of steps to solve a problem. Even though both these have similar symbol, there is a distinct difference between activity diagram and flowchart. So, brief summary lang nung diniscuss ko. UML notation provide comprehensive notation to define specification. Use cases describe functional requirements. Class diagrams defines data of a system. OCL allows expression of detailed functionality and data properties. State machines and activities can precisely describe behavior. Sequence diagram can give examples of behavior. Dito ko pa sir nakuha yung mga ni-research.
Okay, so thank you very much, sir, no, for your discussion. No, again, as I mentioned earlier, when it comes to applications, no, large enterprise application, those that execute core business operational and sustain a business must be more than a collection of code modules. No, they must be structured, no, in a way that enables scalability, no, security, and robust execution under stressful conditions, no, and their structures, often referred to as the architecture. And it must be defined sufficiently so that maintenance programmers can find a fix, a bug that appears long after the original authors have moved on the other projects. Again, actually in our situation, no, it's too easy for us to debug a program if we are the one who developed the program, no. But especially if they don't have a good user's manual or even developer's manual, no, it's too hard for us, no. And in other words, no, the system must be built to function flawlessly in all domains and not just business, no, functionality. Although it certainly is the essential core, no. Obviously, no, I will design architecture is advantageous to any program, not simply the largest one that we have highlighted, of course, and our presenter mentioned, but we need to address large applications first because structure is a technique to deal with complexity. Therefore, the advantages of structure as well as modeling in design, no, as well as illustrate. So multiply as application size increases. Take note of it. Another advantage of structure is that it allows for code reuse, no. The easiest time to arrange an application as a collection of independent modules or components is during the design phase. Eventually, no, businesses amass a library of components model, and each of which, no, represent an implementation container, a library of code modules. So when another application requires an implementation contain a library of code modules. When another application requires the same functionality, the designer can import the module from the library fast. No? At the time of development, the developer can import the code module into the program exactly as rapidly. No? Before coding, of course, modeling is the process of creating software applications, no? Yung UML natin. Because modeling is an essential component of a large software development projects, and it is also beneficial for medium and small enterprises. In a software development per se, no, a model serves as serve the same purpose of blueprints and other plans like site maps, elevations, physical models, no, and in the construction of a skyscraper, no. Using a model, those accountable for the success of a software development project can ensure that business functionality is complete and accurate, no, and users needs are met, no, and the program design support requirements for scalability, robustness, security, and other characteristics before implementation in code makes modifications difficult and costly. In fact, no, it is more likely that a large software application will fail to achieve all of its criteria on schedule and within budget. No, that the would be successful according to some survey. No, so in software, in UML, it is a comprehensive set of diagram types and symbols, but these specific are what make it a standard. So when enterprise architects employ a standard diagramming language, any developer in any organization can work on and any system created by any architect. So I think that's it for this topic.